Hello. Hi. Hello. Okay. Hi. So we are live again, and sorry for the background noises. It seems there is apparently some construction work going on here in my neighbor. So yeah, we'll keep this stream short again, and we'll solve more graded problems. Okay. Today we will solve these two problems. Okay, at least these two problems. First one is collecting numbers. Collecting numbers. So this question I didn't come with the solution. I did not come up with the solution actually. I looked it up, and as it turns out, it is actually very simple. And I had thought about like the way it is solved. No? I had actually thought about it, but never went further with it. So solution is actually very simple. So we are given this array, right, and we need to return how many trips it would take to collect all the numbers if we go left to right, and we take only the ascending we take numbers in only ascending order. So here in first trip we can see that we can only take one number, number 1. Other than that, any the number is not in ascending order. In the second trip we see that 2 and 3 we can take. Okay, and then in the third trip we see that 4 and 5 we can take. So it will take 3 trips to do this. So how are we actually going to solve this? So if we look at this particular problem or a test case, we see that the pairs, okay, that we have to collect, for example 1 and 2, here we see that they are not in the order that we wanted them to. So if it was 1 2 instead of 2 1, then in the first trip we could collect 1 2 and then 3, right? So because it is not that, because the I plus 1th position is less than the position of I. Mouse is not working. Less than the position of I. Okay, because this is the case, we will have to do another trip. So for all the pairs for which this is the case, we will increment the count of trips, okay, which is initially default to 1. Why 1? Because because the number 1, it is always sorted, right, because it is a shortest element. So we will need 1 at least for each array, each test case. So this is 1 set to 1. Then we will check this condition only and then increment the answer based on that. Okay, here in this we can do tyrant as well. See, 2 and 1, it will increment the answer to 2. Then we have 3 and 4, which will increment the answer to 3. Because of these two reversal, we have this issue, right? Okay, so this we have n we have numbers. Okay, and we will use a map. In this map we will store the positions of all the elements. Okay, done. And then I'll have an answer as 1, and we'll check if this map position for I plus 1 is less than its previous number, then in that case we will comment the answer. Yep. Done. Second question, correct numbers 2. Here the question is same, but now we given n operations where we can swap the numbers in the array. So our task is to report the number of rounds after each operation. Okay. Position A and B are swapped, na? Okay. Let's try to do this here. So we have the number, test case. Initially we know that it will take 3 trips, right? Then we swap these two numbers, it becomes 4 1 2 5 3. So it will now take 2 trips only. We swapped 1 and 5, so it will be 3 1 2 5 4. So it will now be 1 2 and 3. Okay, so it will be 1 2 and 3 then. If we swap two numbers, what is actually affected? Anyway, because we are checking only the next elements, or basically the previous element position is in respect to the current one, right? So if I swap 3 and 4, then I need to check for 2 and 5 only. So here 2 and 3 were like sorted in kind of a sorted order. So when I swapped them, I messed that relationship, right? So now 2 and 3 are not in a sorted order. It is like reversed. Similarly for 4 and 5. So I need to check for every swap. I need to check whatever position I have, minimum of xa comma xp minus 1, maximum of xa comma xb plus 1. I need to check their position, and based on that I will update in the map, and then the answer will be updated as well. Okay. So here I swapped 2 and 1, right? So 1 and 2 are now here. So in the map it was like this map. Okay, 1 is in third place, 2 is in second place, 3 is in fifth place, 4 is in first place, and 5 is in fourth place. After the first swap, it is now like this: 1 is in second, 2 is in third. Okay, so for this we will check for third position. How will we check the answer? How will we update our answer? Okay, so I will check for their boundaries. So for 1 there is none, but for 2 we have 3. Okay, so we will check what is the relation of their relative position basically of 2 and 3. So here it is like sorted, kind of sorted, so answer will be decremented. Okay, now after the second iteration we swapped what? We swapped 1 and 5, so these two. Oh, sorry. So we solved 1 and 5. So now it will be 1, 2, 2, 3, 3, 1, 4, 5, 5, 4. Okay, we solved it. Now we will again 3 or 4. We will check for the boundaries 2 and 5. What did we do? So we change their relative positions. Now 3 is before 2, so it will increment the answer by 1. Okay. Similarly, 4 and 5, 5 and 4, they are also not in sorted order, so the answer will be incremented by 1 also. Okay. I will increment the number of such pairs minus 1 to answer. That will work. I cannot just increment it twice. mm, okay, so I also need to check for the after swapping what actually is the relative position, right? uh, so we will check the before and after of each number. So for here 3 and 4 we solved, right? So we will check 2 3 order, we will check 3 4 order, we will check 4 and 5 order. And if we had like 3 and 6, so we will do 2 3 3 4 5 6 and 6 5. Sorry, 6 7. Okay, all these orders we need to check, and then only we'll do change our answer. Okay, let's go. Okay, so we will first make a set of pairs. This is basically I guess we'll call pairs, and I'll have a left which is minimum of x a comma x b. I have a right which is maximum of x a comma x b. I'll put it in the pairs. I'll insert it in the pairs. So first one is left minus 1. So if left minus 1 is greater than 0, if left plus 1 is less than n, pairs dot insert left plus 1. Similarly for right. Now that we have the pairs, we will initialize the D. Okay. So for auto in this pairs, we'll check if P. If P dot first, if map P dot first, if its position is greater than map P dot second. If it is, then D will be implemented. So we have this. Okay. And now after the swapping, so we will swap it. So we'll swap MP X XA with MP XB. Okay. We will do it again. Let's say D1. D2. Then answer is plus equal to D2 minus D. And then say out answer. Two, three, and 4. 2, 3, and 4. Failed. Yes. Almost correct. Time limit exceeded on some cases. What is the limit of M? Okay. This is, I don't think I should take much time, but I think it is because this insert operations. No? I think it is because of this insert operations. So instead of set, can unordered set work? But we cannot make unordered set as pair now. So here it should be 9. Okay. One, two, three, four, five, six. Let me do it again. Hmm. Okay. 5 and 6. Five and 6 is not here. I mean 6 and 5. 6 and 5 is not here. So is swap working daily? Maybe. Temp is MP X so MPX A is equal to MPX B MPX B is equal to temp. But it is 11:20 now. Why is it giving me? Huh. Okay. Okay. This is also okay. Very confused. Okay. Yes, we need to swap the array position also, na? Yes, that is the missing thing. We swapped this, but we didn't swap the arrays. But what about the TLE? TLE. At most 4 pairs. What is the expected time complexity? It is m log n or n log m. What we are doing n plus m, n plus m. Why my time complexity shows there? Pairs will be at most 4 now. So this is just a constant thing. Or if it is just constant. Maybe because of map. That should not be the case. AB is less than n only. Instead of map, should I try using an array? Can try. Yes. Okay. Now we have solved two questions. Should we wrap this up or one more question? Maybe we'll solve one more question. We can try solving. What is this? A very sum with length between A and B. No, I can't do it. Oh, this is binary size problem. K sub-arrays na, so we can try putting it here and here and then see which is the minimum. Maximum sum is as small as possible, so we have to minimize the maximum sum. Yes, it is a binary search problem. We will solve this one. Huh? So okay, so swap array element as well. The next question is array division. So we have this test case. Now we need to divide into k sub-arrays. Okay, so basically we need to put k minus 1 blockers here. So let, for example, here and here. Okay, and we need to give the minimum possible sub-array sum. So for this, the sub-array sum is the minimum, the maximum sub-array sum is 10, which is not minimal. If we put the blocker here, okay, instead of this, if I do this 2 4 7 3 5 and then put the blocker here, and then the minimum, then the maximum sub-array sum is 8, which is minimum. So how will we solve it? So basically we will have a maximum possible sum that we can have. We will start with 0, and let's say we are doing a binary search on answer na. So binary search on answer, so our answer can go from 0 to the maximum sum, which is 2 4 6 7 13 39 and 21. Okay, it can go from 0 to 21. So we will start from the mid value, which is basically 10. So we will try to make the maximum subarray sum as equal to 10. How will we do that? We will make a helper function. Okay, we will keep track of a sum which is currently 0. So here it will be 2, here it will be 6. The moment we see that the maximum sum here will exceed 13, we will put a blocker here, and then it will automatically be we will also do a running maximum sum maximum subarray sum as well. So maximum subarray sum, so till here it is 6. Okay, now it is 7, and we can include 3 in this subarray, so it will be 10 now. So since 10 is less than equal to the required sum or our answer, so we can include this also. Moment we go here, it will be 15, which is not, so we will put a blocker here, divider here, or whatever. So till this the maximum sum is 10, here also it is 10. So yes, it is possible to do answer 10. Okay, it is possible to do it. So we will return a true for 10, and the moment we return a true in binary search, what we will do, since it is true, we will check for if I can find the minimum answer, then this. Okay, if not, then this is the answer. Okay, because I don't want to go, no, if not, then I will go for the right half of the array, or right half of the answer. So since I am dividing this, okay, since this is being divided, so first it is like 10, then it will go for 0 to 10 if it is true, or otherwise it will go for 10 to 21. Okay, then again we will see it is for true, then false. By doing this, we will reach the answer, and this will take the height of this binary search tree will be at most the log of the summation of the array. Okay, so our time complexity will be nothing but this, doing this whatever helper function okay, into this log sum. So it will not take more than n, so big O of n and big O of log sum. So yes, it is in log sum, so we will implement it now. So in 10 k we have x, and start from 0 and is sum. while start is less than equal to end, mid is start plus end minus start by 2. And if check this mid value, this x, this mid and this k, then we will shift to the left sub half. Okay, we will shift to the left half, not sub half. So it will be end is equal to mid minus 1. Otherwise start is equal to mid plus 1. Also answer is equal to this mid. No, time to make this helper function. So we have bool check x, we have mid, we have k. Have a running sum, max sub sum, and k minus minus. Now we will run the loop. So what we will do, I will add the current number, which is xi. We'll check if this sum is greater than the mid. If it is, then k will be if k is less than 0, return false. If it is less than equal to mid, then what we'll do, we'll also do sum is equal to this number, max sum. Okay, otherwise you don't have to do anything. If all is well, then we'll return true. Should work. Eight. Okay, I need to check for this now. If the maximum subsum is double equal to the middle. Mm-hmm. Okay. Yes. Oh, sorry. Done. Okay, so I will wrap this stream up here, and yes, I will meet tomorrow. Maybe not tomorrow. Mm, I don't know. I don't have. I have a hackathon tomorrow, so maybe I will not be. So I don't think I will be able to stream. Let's see. I will update you guys. Whoever is watching. So, yep. Yeah, that's it for this time, and